Okay, so again, you'll want to make sure that you copy down that definition. That definition is really the only thing we're writing down besides the examples. So if you want to write it down right on your example sheet, you can. Imaginary numbers is what we're talking about. I couldn't make this stuff up if I tried, okay? We are actually talking about something called imaginary numbers today. And here's where imaginary numbers come from is, you know how when you take a square root of a negative number and you get no solution, like there's no way to take a square root of a negative and get an actual answer. That really bothered mathematicians, okay? It led to a lot of like dead ends as people were trying to work through more complex equations. You know, they'd get halfway through and have to stop because they couldn't get an answer. So they devised this system of finding square roots of negatives with something called imaginary numbers, and they're imaginary because they don't actually exist, okay? Because they're not actual answers. Now, again, this has some purpose later on as we start to use these things. But as far as like, you know, can you walk an imaginary 5 miles? No, okay? These aren't like a practical number, okay? But again, when we get into like finding roots and things like that, these will have an actual purpose for you, okay? So again, imaginary numbers are sort of made up. I don't want to say that to make them sound like they're not legitimate, but they were created to help us deal with this whole like can't take a square root of a negative number, okay? And I can't write on that. Let's see. Let me switch to this. I would just kind of jot this down right under where you wrote that definition. That what they did, this is how they created imaginary numbers, is they took the letter I and they used that to represent the square root of negative 1. Okay? So anywhere you see an I, that represents the square root of negative 1, which is the most basic imaginary number you can come up with. Okay? So if you look at that first example, if I ask you to find the square root of negative 25, technically, and if you even think about what we were doing yesterday with simplifying the radicals, I could write that as square root of negative 1 times square root of 25. Do you agree with that? I don't know that you're going to want to take the time to write every one of these out this way, but write it down that first time so you know where this comes from. Now, what's the square root of 25? 5. And then what did we say square root of negative 1 was? I. So we write our answer as 5i. It's really that simple. Okay? So when you're taking a square root of a negative, as long as imaginary numbers are fair game, you just take the square root of the number and tack an I onto it. So what would be the square root of negative 36? 6i, yeah. Square root of negative 36 is 6i. You okay with that? Not real earth-shattering or anything, right? Good. Okay. So, example 2 is where we're solving. And you might just want to make a note. When you're solving, that's where we have to worry about using the plus or minus. Okay? So notice up above when I did the square root of negative 25, I didn't worry about positive or negative 5. Okay, I just said 5. When you're solving, that's when you have to say, oh, it could be a positive number or it could be a negative number. And a negative number is different than an imaginary number. Okay, an imaginary number is a square root of a negative number, but you can still have that come out to be negative. So how would you solve that first one? X squared equals negative 100. Square root, okay? And when we square root, we know that we're going to need a plus or minus. What's the square root of negative 100? Nope. 10i, good. So you would say plus or minus 10i. Okay. So just like we were doing before, just when you take the square root of a negative, tack an I onto it. Okay. How about that next one? What would you do first? Okay, I see what you're doing. So you want to move the 55 over here and have it equal 0 and then probably do quadratic formula? We could. You'd be totally fine if you wanted to do quadratic formula. Do you need to? You don't have to. No. Because this one only has a b squared in it and not a regular b, we can solve this kind of just like we did this first one. Okay? I can add 5 to both sides. And I end up with 2b squared equals negative 50. What do you suggest from here? Yep, divide by 2. I'm going to go up over here. End up with b squared equals negative 25. And then I can do what? Square root. And I'm going to end up with b equals, good, plus or minus, oh, sorry, that's a negative 25. Just caught that. Yeah, negative 50 over 2, negative 25. So plus or minus, I'm sorry, 5i. Good. Okay, there you go. Okay. Now, you will eventually encounter them where you are doing the quadratic formula with imaginary numbers thrown in there. It's super fun, I promise. Okay. But for this one, do you see why you didn't need quadratic formula? Okay, because it didn't have that middle term. So, okay. Example 3, we're just simplifying, which just means give an answer. That also means we don't have to worry about our pluses and minuses. Okay. I squared, this is a really important one. Okay, this is going to come up a lot and a little bit today, but even more so tomorrow. Okay, I squared is really square root of negative 1 squared, right? That's what that's saying. What is the square root of negative 1 squared?
1.
Negative 1. Yeah, the square root and the square cancel, and I just get negative 1. Okay? And that right there is a really important thing, that anytime you see I squared, you can replace it with a negative 1. Just a regular negative 1. It's not a square root anymore, because the square would get rid of the square root. Okay? And what that's going to let you do, well, I'll let you see what it's going to do in just a second. Like in this next problem. So if I ask you to do 6i times 4i, Rebecca?
Foil?
You do sort of FOIL, but these are just single terms. It would be like 6x times 4x.
Oh.
See what I mean? So it's not like something plus something and something plus something. Go ahead.
So 6 times 4 would be 24, but it's I squared.
Yep.
It's I times I. The I squared is negative 1, so it's 24 times negative 1, so negative 24.
Yeah, you got it. You took it all the way to the end. I'm going to do it kind of step by step, but you're right. So first of all, is everyone okay with where 24i squared would come from?
Yeah.
So 6 times 4 is 24. I times I gives you I squared. Then we just said a second ago that this I squared is really a negative 1. Again, I don't know that you would need to write this every single time you do one of these, but maybe just so you remember where this came from. This is really 24 times negative 1, which is negative 24 as an answer. Okay? So really, if you have like 5i squared somewhere, I want you to just look at that and go, oh, that's a negative 5. Or, 6i squared would be a negative 6. Okay, anytime you have something with an I squared, it really just turns negative. But notice it doesn't have an I anymore. That's going to be important really more tomorrow than today. But okay, that next one. What's the square root of negative 4? 2i. What's the square root of negative 49? 7i. Now from here, I can treat those just like variables. What would that give me? Good, negative 5i. So act just like they're x's. Okay, so like 2x minus 7x would be negative 5x. Okay. All right, how about square root of negative 36? Going back up here. Okay, this is 6i plus 3 times, how about the square root of negative 4? 2i. Okay. 3 times 2i gives me 6i. So this would be 6i plus 6i, which comes out to be 12i. You got it. Okay. This next one, square root of negative 25 on top would be 5i. Square root of negative 81. 9i. What can I do here? What do you think? Yeah, I can cancel out those i's. Okay, like if you had 5x over 9x, you could cancel them out. Now this 5 over 9 doesn't really reduce, so I would just leave it as 5 over 9. Some people might turn that into a decimal, but good mathematicians think decimals are ugly. So I would just leave it as 5 over 9. Okay? All right, now, next one says square root of negative 12. Is that one that you can just spit out a number for? No. And notice the directions say simplify. Simplify is like what we were doing yesterday. Okay? So we want to try to write this using one of our numbers over there, one of our perfect square numbers. How could I do it?
4.
Okay, so I could write this as 4 times 3, right? What am I missing? Negative, right? Now you technically could, I guess it depends on how much you want to break it down. You could just stick that negative on that 4, right? Because when you take a square root of that, that's just going to give you an I. Or you could make the negative its own separate thing like that. Okay, it doesn't really matter. So this is going to give me an I. This is going to give me a 2. And this is going to just stay square root of 3. Everyone okay with those 3 pieces? And then when you put it together and write it kind of the correct way, it would be 2i square root of 3. Okay. So see what I mean? That I could have just made that 4 a negative 4, and then when I took the square root, just said it was a 2i. So you could have pulled that all out at once. Okay, Erica?
What if that 12 was a number like 41, where it like wouldn't go into it, or
That's
there
a-
was nothing that would go into it?
Great question. So just going to kind of throw this in here. That's a great example. So if it was a square root of like negative 41, the only thing you could do with that is make it like negative 1 times 41. And then you can pull out an I, but then you would just leave the 41 alone. Okay? So you would write it with an I on the outside to show that it's imaginary, but then just leave the square root of 41 by itself. Okay? Good question. Everyone okay with that? Good there? Anything there that seems like it's going to be tough? Okay. Let's just hit example 4 real quick, and then we can get on with our lives here. Show that I square root of 7 is a square root of negative 7. I want you to pay attention to this word show, okay? Because what I get a lot of people doing is they just take the square root of negative 7 and they do what I did right here, and they say, oh, look, that's the answer, okay? But if I, as a teacher, was trying to show you that the square root of 25 was 5, okay? If my job was to show you why that was true, how do you think I would do it? How do you think I would prove to you that the square root of 25 was 5? Daniel?
You show us that 25 divided by 5 is 5.
Okay, but our square root's really doing division. Just be careful here. Other thoughts? Like, I could just say, if I was a bad teacher, I could just say, well, the square root of 25 is 5, because when you put it in your calculator, it gives you 5 as an answer. But that doesn't really explain to you why. Why is the 5 equal to the square root of 25? Andrew?
Because 5 squared equals 25.
There we go. That's what I would do to convince you, right? Is I would say, hey, look, if you take 5 and square it, you get 25. That's what a square root is the inverse of a square, okay? So what we are going to do here, if we want to show this, we're going to take that I square root of 7 and square it and show that it's going to turn into that negative 7, okay? We want to show that it's equal to the square root, so I'm going to get rid of that. This isn't hard to do. When you square something like this, that square kind of gets distributed. So what you're really going to end up with is this. I squared times square root of 7 squared. Now what? Robert?
Since the 7 is being squared and the I is already negative 1 squared.
Yep.
Both of those cancel, it's just negative 1 times 7.
Yeah, that's exactly right. So this, the square root and the square cancel, and that's going to give me just a 7. And then we already know I squared is equal to -1. So this really now just says -1 times 7, which is -7. And that's how you would show, hey, look, when I take this and square it, it turns back into -7. Okay? And that's it. That's what I would do. I would just leave that on my paper and have that be my proof. Feel okay on that? Okay. Homework then is in your homework packet. It should be the next page. It's Lesson Master 6-8B. You are doing front and back, and I know it looks like a lot of problems, but the whole back side is just stuff like this that are going to go really quickly. Okay? So you are doing the whole thing, 6-8B. The front side is where you're solving, and that's where you're doing the plus or minuses, kind of like example 2 on this page. I'm going to leave it up to you as to whether you want to give decimal answers, like with a calculator, or whether you want to simplify them and leave them as exact answers. Okay? You'll need practice with both, so it's up to you which way you want to go. Most of them are easy, like our example 2 was. There are a couple where you're going to have to do quadratic formula. Okay? And then the whole back side is all problems like this example 3. Okay? Go ahead and get to work. I don't know where we're looking at time-wise, but you should have some time to get started.